Welcome to the third lesson of CSEC Physics with Edu Solutions Institute. So today's lesson we'll be looking at density. Now, what exactly is density? What's the formula for finding density? And what's the unit that we use to report density, right?
Density is a measure of how compact the mass in a substance or object is. If each meter cubed weighs more, the substance is more dense. As we'll discuss in other lessons, density is super important because it relates to whether things rise or sink. Denser materials tend to rise above less dense materials, particularly in the case of liquids and gases. So understanding density has major implications for the motions of materials and gases in the atmosphere and objects floating or sinking in water. Density is the reason some objects sink and other objects float, and it's the reason that some clouds are high in the sky while others are low down. Density means that if you take two cubes of the same size, made out of different materials, and weigh them, they usually won't weigh the same. It also means that a huge cube of styrofoam can weigh the same as a tiny cube of lead. Examples of dense materials include iron, lead, or platinum. Many kinds of metal and rock are highly dense.
So density, first and foremost, is how compact particles are within a substance. And what that means is we have particles that make up everything that's present. So therefore, those small particles within objects, how closely are they to each other? So it doesn't matter the size of the object, right? It has to also do with how closely those particles are. Because as you know, an object could be very big or an object could be small, right? But this small object will have more density than this one because it's dependent on these little particles that they have. In the big one, if they are widely spread out in comparison to the smaller one, where these particles are very close to each other. So because they're close to each other, we have more of the particles than the bigger object. So because we have more particle within this smaller area, smaller volume than the bigger one, then this one will have more density than this object, right? So density in calculation wise would be the mass of the object divided by its volume, right? And in symbol form, because at physics we will use symbols instead of words when we're doing our calculations. So in this case, this symbol, it's not a P, it's a Greek symbol, and it's called rho. And rho is used to represent density, right? So it's a curved P if you want to use that description, and it is mass, which is measured, is a symbol, common M, and volume, which is a symbol of a capital V, right? So that's this unit, that's the formula that we use to represent density. Now, the next part is what is the unit that density is measured. So in density, we have our SI unit of rho, which is, we can replace our symbols here with their units. So we know mass is measured in kilograms for its SI unit, and volume is measured in meter cube for its SI unit. So in this case, the unit of density would be kilograms slash m cube. So we don't use this division sign, we use a slash, and that slash means per. So whenever you see a unit that has slash in it, it means per, and that per means it was divided by that unit. So in this case, kilogram is being divided by meter cube. Or we could write it as without the slash, so it's kilogram meter. So to represent that this was divided, we take this up, so it becomes a -3. So the negative here also represents that it is a per, right? So it's the negative or slash that means per, which means this part was divided by the kilogram part. Now we also have other unit that we use for density. It's not the SI unit, But we can also have calculations using that, which is instead of kilograms for the mass, we have grams. And then instead of volume being in meter cube, we have centimeters cube. So these are the two units that you'll see density being measured in. Once the question requires you for SI unit, we use the kilogram per meter cube. If it didn't specify, then you can use gram per cm cube. So let's look at a question. Now this question will help us to understand how to utilize this formula. So, let's say we have an object of mass 35 grams and volume of meter cube. Calculate its density. Right? So the first thing that I like to do with calculations in physics is to identify the numbers and what they represent. So we know 35 grams here is your mass. So we have our symbol for mass and it's 35 grams. We also have this here, which represents, based on the unit, it's its volume, which is 0.0002 meters cubed. Now, if we notice here, we have two things, right? First thing we do is to compare the units. Do these units match, or are they compatible with each other? So based on our symbols or units over here, we see that kilogram goes with meter cube, and we see that gram goes with centimeter cube. So here we have grams. So down here, we should have centimeter cube to do our calculation, but we don't. All right, so we have meter cube here. So up here should be kilograms, which is not. So therefore, all we need to do is to convert one of these first. So let's convert this one to kilograms, which is easier. How do we convert to kilograms? We divide the number by 1,000. So this is 0.035 kilograms. Now we have kilograms and meter cube. So therefore, we can find density. We write the formula and then we substitute, which is 0.035 divided by 0.0002, right? Which is 350 over 2, which is 175 unit kilogram meters kilogram per cubic meter, right? Now, very easy to do. Now, let's identify. Let's say we wanted, instead of changing this gram to kilogram, to change the meter cube to centimeter cube. So in that case, to change this to centimeters cube, this is where students get mixed. Students would do this, 0.0002 times 100, because they're saying meters to centimeter is 100, but this unit is meter cube to centimeter cube. So just like when it's just meter to centimeter, it's 100. If it's cube, then we have to cube the 100 as well, which is multiplying this number by 1 million. And in that case, we will get that centimeters cube. And hence, if we divide 35 by 200, what you will actually get is 0.175 gram per cm cube. And what this shows us is that to convert between these two units of density is that 1 gram per cm cube is equal to 1,000 kilogram per cubic meter. So this is also a relationship that you can use to identify your values. All right. Now, a popular constant that you need to know the density is the density of water. The density of water H2O is 1 gram per cm cube, or it's 1,000 kilogram per meter cube. Now, before we close, density is unique. It helps us to simply do calculations to explain one way in which objects float or sink within a specific liquid. So if we take water, for example, why does a leaf float in water and a nail will sink? Right? Because the leaf density is less than a nail's density. So that principle is called relative density. And relative density is we do the density of the substance over the density of the water that we're placing the substance in. And once that value is less than zero, what that relative density tells us is that the object will float. And if it is greater than zero, greater than one, sorry, then it tells us that the object will sink because it's more dense than the water that we're putting it in. So relative density helps us to explain flotation and sinking of objects within a specific liquid. All right, so that's it for today's lesson. Hope you learned something new today, and I'll see you next week where we continue the CSEC physics syllabus. Thank you and see you soon.